Okay, I'm Donovan Wixom. I'll be doing problem 3. Part A of problem 3, it says to determine the gene arrangement of these linked genes. So for that, you just look at the chart and find the two highest number outcomes, highest number of offsprings. So for this problem, that is a recessive C with a wild type G S on top, and a wild type C with a recessive GS on the bottom, because there are 484 offsprings here and 441 offsprings here. That's part A. Okay. Part B, it says to determine the order of these genes. So to do that, you have to find the double crossover generations, which are the lowest ones. Double cross over, which are the lowest ones on the chart. For this chart, there's only 6 points, which means 2 of the points didn't happen at all. There were 0 offspring made. And those are going to be our double crossover events because they happen the least. They happen 0. And those are going to be recessive, how do I write this? Recessive G, wild type CS with 0, and wild type G with the recessive CS, again, with 0. And then you have to kind of look, I just looked at how this differed from this and kind of came up with this recessive C, so C, S, and then G. And again, C, S, and then G. You check that to make sure that that's right. So when the crossover does happen, double crossover does happen, you're getting a recessive C, S, and a wild type G. That's this one. Or you're getting a wild type C, S, and a recessive G, which is that one. So that is our order. Our order is C, S, G. Part C is to create a linkage map. So now we have to look for the single crossover events. I started with a cross happening right here between C and S. So we're looking for where these two are going to stay the same and these are going to switch. So the first one would be all wild types. And the second one would be all recessive. And if you just look on the chart to get those numbers, you get 27 and 29. Then to find the distance, you add up the double crossover events, which were 0, with the single crossover events, 27 plus 29, divide it by the total number of offspring, which was 1,000, and times it by 100. If you plug that into your calculator, you get 5.6 map units. So the single crossover events that occurred between S and G, you do the same thing. We want these two to stay the same and that to be different. So you get a wild type C, a recessive S, and a wild type G. A recessive C, a wild type S, recessive G. Again, you just look at the charts for these to get the numbers. Let me make sure I'm putting the right number in the right spot. 11 and 8, that's an 8. And you do the same thing with your math. 0 plus 0 plus 8 plus 11 over your total number of offspring times 100 gives you 1.9 map units. And then you just make a linkage map with those numbers. So 5.6 map units. 1.9 map units. And that's what our linkage map is going to look like. And finally, for part D, you want to find the interference. You find the interference by taking your map distances, putting them over 100, and multiplying them together. That's how you start. So we'll do that. 5.6 over 100, 1.9 over 100. Multiply those together. Let's see, where did I put my math? You get 0.106%. Then you would times that by our total number, which is 1,000, which gives us, where did I put it? Right here. 1.064 double crossover events that we expected to happen. What we actually had happen is none, right? We had the 0 plus 0 equals 0. So when you use our interference equation, 1 minus our actual, our observed over what we expected, 1.06, that's going to equal 100%. 100% interference. That's it.